Hi, good afternoon. We are the group 1 and for today's video, we're going to discuss about the selection sort of algorithm. To begin with that, what is selection sort? It is a simple sorting algorithm. This sorting algorithm is an in-place comparison-based algorithm. The smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes a part of the assorted array. This process continues moving unsorted array boundary by one element to the right. Next. In selection sort, we maintain two parts, the sorted subarray and unsorted subarray. Next. Steps in illustration on how to do selection sort. Next. Logic. Array is considered into two parts, unsorted and sorted. So here, as I said earlier, the selection sort has two parts, the unsorted and sorted array. For selection, select the lowest element in the remaining array. So here in the selection sort, we have the jumbled arrays, which is we need to select the lowest element in the array, and then for swapping, transfer it to the starting position. And for counter shift, change the counter for unsorted array by 1. This when the number is has no it has the what do you call that, the number is there has no next in the array, in the remaining array, so it will remain in its position. Next. So here we have the unsorted arrays. Mm, and for the first position in the sorted list, the whole list is scanned sequentially. The first position where 70 is stored presently. So we search the whole list and find that 10 is the lowest value. Next. So we replace 70 with 10, and after one iteration, 10, which happens to be the minimum value in the list, appears in the first position of the sorted list. Next. For the second position, where 37 is receding, we start scanning the rest and of the list in the linear manner. So we find that 13 is the second lowest value in the list, and it should appear at the second place. So we swap these values, and after two iteration, two list values are positioned in the sorted array, and the same process will do at the rest of the item in the array. Next. Same process. So the counter shift, which I said earlier, the 37 will remain in its position. Next. Same with the 70, the counter shift. There we have it, the sorted array. Then now we will go on to pseudocode.
So a pseudocode is an artificial and informal language that helps programmers develop algorithms. So a pseudocode is a type of code which helps programmers develop algorithms. So it is just basically a code, but you will develop algorithms in this type of code. So right here, we have a selection sort example code in Python. But later on, we will be simulating this code to you guys. So as you can see, this is an example of a selection sort code. So let's simulate the code. So here we are right now in PyCharm, which is an IDE for Python programming. So we used Python for this pseudocode since we believe that Python is a very easy to use programming language. So as you can see in this code, we used an array. It's an array since it iterates over an object until the object is complete. So we first define our function, which is selection sort. So define selection sort, and then array, which is we will be using an array for selection sort, and then the size of the array. So then we used a for loop, since for loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string. But in this case of selection sort, we made a list of numbers. So with the for loop, we can execute a range. We can execute a set of statements once for each item. So now we make our for loop here. So for step, so step here is defined as an integer, and then range, and range is the range of the array. So where it will start, and when will it end, and the size is the size of the array. So the size here is not specified, so any size of an array will do. So for our minimum index is step. So the minimum index in this code is the integer step. Then next one for I in range, step plus 1 size. And now after that we use an if statement. So an if statement decides whether certain statements need to be executed or not. So it checks for a given condition. If the condition is true, then the set of code present in the if block will be executed. So here, if array I is less than the array minimum index, automatically the minimum index will go to the I array. And then so right here, as you can see here, this is the array. This is the unsorted array right here, data. So we have numbers here, 70, 37, 13, 25, and 10. And then the size is the length of the array, the length of data. And selection sort, data, and then size. And then we inputted here to print out sorted array in ascending order. So if we run this code, it will automatically sort out the numbers in ascending order. So let us see if this selection sort code is working, if it's ever true. So let us run, and there you go. So the selection sort array, or the sample code of selection sort in Python is true. So it is working. And that is it for the simulation of code. Let us now proceed to the time complexity.
Now let's proceed to the time complexity. So what is time complexity? It is the computational complexity that describes the amount of computer time it takes to run an algorithm. What is the time complexity of selection sort? Let's find out by looking at this illustration. So as you can see here, there are highlighted red, this box right here, little box, it indicates the sub-arrays or the arrays that has not been sorted. So as you can see, there is a red and green. So this red right here, it indicates that this is the unsorted arrays. The green one are the sorted arrays in selection sort. So, um, when you try to sort an array, it will run a 5 comparison to find minimum. And then, next step, 4 comparison to find minimum, and so on. So, as you can see, overall, there are, if you will add or compute the comparison in each sub-arrays to have the complete sorted arrays, it is equal to 15 comparisons. So these 15 comparisons right here will show us on how to get the time complexity of the selection sort. Next doll. So here, as you can see, 15 is the equal comparison of each sub-arrays in the illustration. So this 6 right here, as you can see, 6 times 5 times 1/2. 6 right here indicates indicates the sub-arrays. If we replace 6 by n, we get n times n minus 1 in parentheses times 1/2. It is enough for us to see that the term contains n times n. Therefore, in the final term is n squared or O(n) squared, which means quadratic time. Therefore, the time complexity of selection sort is O(n) squared. So in time complexity, there are 3 cases. These are worst case, average case, best case. So these 3 cases right here, they are in selection sort, they are all have the same time complexity result, which is the O(n) squared. Now, let's go to the worst case. Here, in the worst case, this happens when the array is already sorted with one swap, but the smallest element is this last element. So as you can see in the example, the red column here indicates that these are the smallest elements. As you can see, they are not in ordered, or they are the smallest element are not in place. So this, which means this lead us to the worst case of the selecting of sort. So next, therefore the worst case has n times n plus 1 or 2 comparisons with n swaps. So again, the time complexity here in worst case is O(n) squared. Now, in best case, this happens when the case of an array is already sorted. So just like here in our example, the blue one highlighted column is the unsorted subarray, which means they are not in ordered or they are jumbled. So as you can see in the green part column here, the lower part, these are the sorted subarray. Here, you can observe that they are in ascending order, or they are in the they are in ordered. Next one. So in best case, the time complexity is also the same. Just like what I've said earlier, they are both the same, which O(n) squared. Therefore, the best case has n times n plus 1, say Therefore, the best case has n times n plus 1 or 2 comparison with 0 swaps. Now, in average case, this case happens when the elements of array are in jumbled order, which means they are not in ascending order or they are not in descending order. The time complexity for this case is also O n squared. So therefore, n has the same comparison, which is n times n plus 1 or 2 comparison with n swaps. They're both the same with the worst case. So there you have it. This is the summary of our report. Selection sort has two parts. These are unsorted subarray and sorted subarray. It is the process of choosing the smallest element or unsorted array and transferring it to the front. It has a time complexity of O n squared that applied to all cases. These are worst case, best case, and average case. So that's all for our report. I hope you understand something. This is presented by me, Tabuan Kashmir A, and Keno, Shan, Sheldin, and also Abdul Wahab for Shana Majid. So thanks for watching.